Welcome to the deep dive. Today, we're diving into a fascinating uh, new way of thinking about artificial general intelligence, AGI. Specifically, how to make it safer and more transparent. We've got some really cool source material for this deep dive. Notes on something called modular AGI architecture and iterative deployment strategies, plus some data tables full of numbers relating to AGI development. We'll get into those later. So, how do we build an AI that's not only super smart, but also safe and understandable? Like, what even is a modular AGI?
Well, that's the exciting part, right? With my background in AI safety and development, I can tell you this modular approach is a pretty big deal, especially with this focus on risk assessment and error correction. Those are some of the key things we're going to be looking at today.
Okay, I'm all ears. Let's start with this whole modular AGI thing. It's kind of like building with Legos, right? Breaking down a complex AGI into smaller, more manageable pieces.
Yeah, it's a great way to think about it. Each module has a specific function, and we can understand and control these individual pieces much more easily than trying to wrap our heads around the entire AGI all at once.
Makes sense. And then there's this idea of iterative refinement. So we're constantly tweaking and improving these modules over time, right? Like fine-tuning a machine to get it running perfectly.
Exactly. Yeah. This iterative process is key to making the AGI safer and more reliable. Think of it like training a dog. You start with simple commands, reward good behavior, and gradually increase the complexity as the dog learns. We're doing something similar with AGI, using these iterative cycles to guide its development in a controlled and predictable way.
And speaking of cycles, our source material includes some data tables that track the AGI's progress through these iterations. For instance, there's a column labeled fractal dimension. And it seems to change with each cycle. What's the significance of that?
That's where it gets really interesting. Fractal dimension it's a way to measure the AGI complexity. Think of it like measuring the intricacy of a snowflake's pattern. The higher the fractal dimension, the more complex the AGI, capable of handling more intricate tasks and relationships.
So if we see the fractal dimension increase from, say, 1.2 to 1.8, what does that tell us about the ADAI?
That's a great question. That kind of increase suggests that the AGI is moving beyond simple tasks and starting to understand more complex relationships, like those found in social dynamics or creative problem solving. It's like watching the AGI's brain power grow in a way we can actually, measure and track.
Okay, that's starting to paint a clearer picture. But all this talk about complexity makes me wonder, how do we make sure this super smart AGI doesn't, become too smart for its own good?
Right. That's the million-dollar question. And it's where this constant risk assessment comes in. Think of it like having a safety inspector on site at all times.
Okay, so how does this risk assessment actually work? I see things like risk assessment score and previous error impact in these data tables. What are those all about?
These are some of the tools we use to monitor and control the AGI's potential for harm. The risk assessment score gives us an overall picture of how likely the AGI is to cause problems based on a variety of factors.
And what about previous error impact? Is that like looking at the AGI's report card to see how it's been behaving?
Exactly. Previous error impact tells us how much damage, if any, was caused by previous errors. This helps us understand the potential consequences of future errors and adjust our safety protocols accordingly. It's like learning from our mistakes, but on a much more sophisticated level.
Right, because with AI, even a small error could potentially have a big impact, depending on what the AGI is controlling or influencing.
Precisely. That's why we're constantly monitoring these metrics and looking for any red flags that might indicate the AGI is heading down a dangerous path. We're not just hoping for the best, we're actively managing the risks every step of the way.
Okay, so we've got this modular AGI that's constantly being refined and assessed for risk. What else do we need to consider in terms of building safe and transparent AGI?
One crucial aspect we haven't talked about yet is decision cost. It's a measure of how much computational power and potential real-world impact each decision that AGI makes requires.
So if the decision cost is high, that means the AGI is using a lot of resources and potentially having a greater impact on its surroundings.
Exactly. And that's something we want to keep an eye on because efficiency is a key factor in safe AI development. We want the AGI to be able to make smart decisions without consuming excessive resources or causing, unintended consequences.
Makes sense. So lower decision cost scores are generally a good thing, right?
Absolutely. Lower decision cost often indicates that the AGI is becoming more efficient in its decision-making processes. It's figuring out how to achieve its goals with less effort, which is a promising sign. It means it's learning and adapting.
That's fascinating. So it's not just about building a super smart AI. It's building a smart and efficient AI that can learn and improve over time.
Exactly. It's about building an AI that's not only intelligent but also wise in its use of resources and its impact on the world around it. And that brings us to another key concept: error correction.
Right. It's not enough to just identify errors. We need to be able to correct them.
Right, absolutely. And that's where the beauty of this iterative approach comes in. Just like humans learn from their mistake, the AGI is constantly learning and improving through its cycles of making decisions, being evaluated, and having its errors corrected.
So it's kind of like having a built-in feedback loop. The AGI makes a decision, we see how it plays out, and then we help it adjust its course if needed.
Precisely. And the faster we can correct those errors, the more robust and reliable the AGI becomes.
That's incredibly reassuring to see that safety is baked into every step of the process.
It is, and it's not just about safety. This real-time correction process also contributes to transparency. By understanding how the AGI learns from its mistakes, we gain a better understanding of its internal workings.
Ah, that makes sense. It's like having a window into the AGI's thought process so we can see how it's arriving at its decisions.
Exactly, and that transparency is crucial for building trust between humans and AI. We need to be able to understand how the AGI is operating, not just blindly accept its outputs.
So we're not just building a black box. We're building a system that we can understand and interact with on a deeper level. I'm really liking where this is going, but we've still got a lot to unpack.
Oh yeah, we are just getting started. There's a lot more to discover in these data tables. For example, you mentioned complexity score earlier. That's another key metric we use to ensure the AGI remains understandable and manageable.
Okay, right. Remind me, how does complexity score fit into all of this?
It helps ensure we don't accidentally create an AGI that's too complex for us to understand or control.
Ah, that makes sense. We don't want to end up with an AI that's so advanced we can't even figure out how it works. Right? That could lead to all sorts of unintended consequences.
Precisely. And remember, the whole point of this modular approach is to break down complexity into manageable chunks. So by keeping an eye on the complexity score, we can make sure we're not letting things get out of hand.
Yeah, it's like having a built-in safety valve, right? We can adjust the complexity level if needed, making sure we don't lose sight of how the AGI is operating.
Exactly. We can fine tune the recursion depth, adjust the fractal patterns, and ensure the AGI remains within our grasp. Think of it like setting the difficulty level in a video game. We want it challenging enough to be engaging, but not so difficult that it becomes frustrating or impossible to play.
I like that analogy. Makes it much easier to understand. So we've got modularity, risk assessment, error correction, and complexity control. Are there any other key components to this safe AGI approach we should be aware of?
One more crucial element to consider is prediction confidence. It tells us how sure the AGI is about its predictions, which is crucial for transparency because it allows us to assess the reliability of the AGI's outputs.
Oh, that's interesting. So if the prediction confidence is low, that means the AGI is basically saying, "Hey, I'm not entirely sure about this, so take my prediction with a grain of salt."
Precisely, and that's a good sign, believe it or not. It means the AGI is aware of its own limitations and isn't afraid to express uncertainty. It's a sign of humility, which might sound strange to say about a machine, but it's a valuable trait in any intelligent system.
Okay, I'm starting to see how all these pieces fit together. So we've got a modular AGI that learns from its mistakes, constantly assesses risk, remains understandable to humans, and is honest about its own limitations. This iterative deployment cycle seems like a truly groundbreaking approach.
It is, and one of the most exciting aspects is how it can potentially transform various industries. Just imagine the possibilities in healthcare, transportation, or even something like personalized education.
You're right, the possibilities are endless. But before we get too carried away, I want to make sure I understand this iterative deployment cycle correctly. It's basically a continuous loop of building, testing, learning, and refining, right?
Exactly. Think of it like a spiral staircase. With each iteration, we climb higher, gaining more knowledge and improving the AGI's capabilities, while always prioritizing safety and transparency.
And all these metrics we've been discussing, risk assessment score, decision cost, complexity score, and prediction confidence, they're all part of this continuous monitoring process, right? Helping us make sure the AGI stays on track.
Precisely. They're like the instruments on the dashboard of a car, giving us real-time feedback on the AGI's performance and helping us steer it in the right direction.
This is all starting to paint a very optimistic picture, but I'm also curious, is there anything in the source material that hints at potential challenges or limitations with this safe AGI approach?
That's a crucial question to ask. While this approach is incredibly promising, it's important to remember that no system is perfect. There are always potential challenges to consider.
Okay, so what are some of the hurdles we might encounter along the way?
Well, for instance, determining the appropriate level of complexity score can be tricky. If we set it too low, the AGI might not be powerful enough to tackle a complex problem. But if we set it too high, we risk sacrificing transparency and controllability.
That sounds like a delicate balancing act. We need to find that sweet spot where the AGI is capable, but still comprehensible.
Exactly. And even with all the safety measures in place, there's always the possibility of unforeseen errors or biases emerging as the AGI evolves. It's an ongoing process of learning and adaptation for both the AGI and for us as developers.
So it's not a set it and forget it system, right? We need to be actively involved in guiding its development, monitoring its performance, and adapting our safety protocols as needed.
Absolutely. Safe AGI isn't about removing humans from the equation. It's about creating a partnership where where humans and AI can work together to solve problems and create a better future.
I love that perspective. It's not about replacing human intelligence. It's about augmenting it, creating a powerful synergy between human ingenuity and AI capabilities.
Precisely. It's about combining the best of both worlds to achieve outcomes that wouldn't be possible otherwise.
But as we've seen, it's not just about raw power. We need to prioritize safety, transparency, and ethical considerations every step of the way.
And that's precisely what makes this iterative deployment cycle so compelling. It's a framework for building AGI that's not only intelligent but also aligned with our values and aspirations as a society.
So this safe AGI approach isn't just a technical solution. It's a philosophical approach to AI development. It's about building AI that serves humanity, not the other way around.
Couldn't agree more. It's about ensuring that AI is a force for good in the world, helping us to solve complex problems, unlock new possibilities, and create a brighter future for everyone.
I'm feeling inspired, but before we jump into a full-blown utopia, let's bring it back to the source material. What other insights or data points stood out to you that might help our listeners understand this? Safe AGI approach, even better.
One thing that that really struck me was the interplay between prediction confidence and error correction in the time step data. I talked about it briefly earlier, but I think it deserves a closer look because it highlights a key difference between this safe AGI approach and some of the more traditional AI development methods.
Okay. Tell me more about that. I'm curious to see how those two elements interact.
As the prediction confidences dip slightly, the error correction kicks in to nudge the AGI back on course. It's almost like a self-correcting mechanism, a built-in safety net that prevents the AGI from veering too far off course.
So even when the AGI isn't entirely sure about something, it's still able to learn and adjust its approach thanks to this error correction mechanism.
Exactly. And that's what makes this approach so robust. It's not about creating an AI that's always right. It's about creating an AI that's always learning and improving, even when it makes mistakes.
That's a really important distinction. It's like saying it's okay for the AI to be wrong sometimes, as long as it learns from those mistakes and gets better over time.
Precisely. And the beauty of this real-time error correction is that it allows the AGI to adapt and improve quickly, making it far more robust and reliable in the long run.
This is all incredibly fascinating, but I have to admit, even with all these safeguards in place, a part of me still wonders, what if something goes wrong? What if, despite our best efforts, the AGI makes a mistake that has serious consequences?
That's a perfectly valid concern. And to be honest, no system, no matter how sophisticated, can guarantee absolute safety. There will always be unforeseen challenges and the potential for things to go wrong.
So it's not about eliminating risk entirely, but about managing it intelligently and having backup plans in place.
Precisely. We need to be realistic about the limitations of any technology, even one as advanced as AGI, and that's why transparency is so crucial.
Okay. So remind me again, why is transparency so important in this context?
By understanding how the AGI is making decisions, we can identify potential weaknesses and develop strategies to mitigate those risks. It's like having a detailed blueprint of a building, allowing us to identify potential structural flaws and reinforce them before they cause a collapse.
That makes sense. So transparency is not just about making the AGI's inner workings visible. It's about enabling us to anticipate and prevent potential problems before they occur.
Exactly. And the modular design also plays a key role in risk management.
How so?
If one module malfunctions, we can isolate it and potentially even replace it without disrupting the entire system. It's like having a set of spare parts for your AI ready to swap in if needed.
That's a great analogy. It makes me feel a lot more confident about the potential of Safe AGI. It seems like this approach is as much about careful planning, human oversight, and constant vigilance as it is about clever algorithms and data analysis.
Absolutely. It's about recognizing that building safe and beneficial AGI is a collaborative effort, requiring both human and artificial intelligence to work in harmony.
We need to bring together the best of human ingenuity and the power of AI to create something truly remarkable. But we can't forget that this partnership needs to be built on a foundation of trust, transparency, and a shared commitment to safety and ethical considerations.
Couldn't have said it better myself. It's about creating a future where AI empowers humanity, not replaces or endangers it, and that's a future worth striving for.
Agreed. But before we wrap up, I'm curious to hear your thoughts on something. We've talked a lot about the technical aspects of Safe AGI, but what about the human side of things? How do we ensure that the people developing and deploying these systems are doing so responsibly and ethically?
That's a crucial question. Ultimately, the success of Safe AGI depends not only on the technology itself, but also on the people who create and utilize it.
You're right. We need to ensure that the people behind the AI share the same values of safety, transparency, and ethical conduct. But how do we make sure that happens? Are there any guidelines or best practices in place to guide ethical AI development?
That's a great question, and one that's being actively discussed and debated within the AI community. There's a growing recognition that we need to establish clear ethical guidelines and standards for AI development, similar to the ethical codes that guide professionals in fields like medicine and law.
So it's like creating a Hippocratic oath for AI developers, a set of principles that guide them towards responsible and ethical conduct.
Exactly. We need to foster a culture of ethical AI development where safety, transparency, and accountability are paramount, and that starts with education, open dialogue, and a willingness to engage with diverse perspectives and address potential concerns.
So it's not just about building safe AI, it's about building a safe and ethical AI ecosystem, one that includes not just the technology itself, but also the people, the policies, and the societal values that shape its development and deployment.
Precisely. It's a complex challenge, but one that we must address if we want to harness the full potential of AI for good.
It's a multifaceted challenge that requires uh, careful consideration and collaboration from various stakeholders, including researchers, developers, policymakers, and the public.
You're absolutely right. It's a conversation that needs to involve everyone, because ultimately the future of AI is a future that we will all share.
Well said. And as we wrap up this part of our deep dive, I'm struck by the importance of that shared responsibility. We can't simply leave the development of AI to a select few. We need to engage in a broader conversation about the future we want to create with this powerful technology.
I couldn't agree more. The future of AI is too important to be left to chance. It's a future that we must shape together with wisdom, foresight, and a deep commitment to ethical principles.
Yeah, it really is. It's mind-blowing to think about all the possibilities and the potential impact AGI could have on our world.
It is. It's a future filled with incredible possibilities, but also one that demands careful consideration and responsible stewardship.
Absolutely. But before we get ahead of ourselves, we still have some more ground to cover in our source material. Is there anything else that stood out to you that we haven't discussed yet?
Yes, actually, I think it's worth revisiting the error correction column in the time step data. We talked about it briefly earlier, but I think it deserves a closer look because it highlights a key difference between this safe AGI approach and some of the more traditional AI development methods.
Okay. I'm all ears. What's so special about the way error correction is handled in this system?
Well, in traditional AI systems, errors are often seen as failures, something to be avoided at all costs. But in this iterative approach, errors are viewed as opportunities for learning and improvement.
So instead of punishing the AI for making mistakes, we're actually encouraging it to make mistakes as long as it learns from them.
Exactly. It's like saying to the AI, "Hey, it's okay to stumble as long as you get back up and keep moving forward. We're not expecting perfection. We're expecting progress."
That's a really refreshing perspective. It's like we're shifting from a culture of AI infallibility to a culture of AI learning and growth. But how does this error correction process actually work in practice?
Well, imagine the AGI is trying to solve a complex problem, like predicting the stock market or designing a new drug. As it works through the problem, it's constantly monitoring its own performance and looking for any discrepancies between its predictions and the actual outcomes.
So it's basically doing a self-assessment, checking its own work to see where it might be going wrong.
Precisely. And whenever it detects an error, it triggers a correction mechanism that analyzes the error, identifies the underlying cause, and adjusts its internal models accordingly.
So it's not just fixing the mistake; it's figuring out why it made the mistake in the first place, and then taking steps to prevent that same mistake from happening again.
Exactly. It's a process of continuous learning and refinement, a bit like how a student might review their mistakes on a test to understand the concepts they need to study more.
That's a great analogy. Makes me wonder, does this error correction process ever end, or is the AGI constantly learning and evolving even after it's been deployed in the real world?
That's a great question, and the answer is that learning never truly ends. Even the most advanced AGI will continue to encounter new challenges and make occasional mistakes as it interacts with the ever-changing complexity of the real world.
So it's not a matter of reaching some end point of perfect AI. It's an ongoing journey of learning, adaptation, and improvement.
Precisely, and that's why this iterative approach is so well suited for developing safe and reliable AI. It embraces the reality that AI is not a static entity, but a dynamic, evolving system that needs to be constantly monitored
Refined.
and guided in a responsible and ethical direction.
That makes a lot of sense. I think we're acknowledging that AI, like any complex system, will inevitably have its quirks and imperfections. But by embracing those imperfections and building in mechanisms for learning and adaptation, we can create AI that's not only powerful but also resilient and trustworthy.
Exactly. It's about moving beyond the hype and the fear surrounding AI and embracing a more realistic and nuanced perspective that recognizes both its potential and its limitations.
Well said. It seems like we've covered a lot of ground in this deep dive. Exploring the intricacies of Safe AGI, from its modular architecture and iterative deployment cycle to the crucial role of risk assessment and error correction, I'm walking away with a much deeper understanding of how we can build AI that's not only intelligent but also safe, transparent, and aligned with our values as a society.
I'm glad to hear that. And if there's one thing I hope our listeners take away from this discussion, it's that safe AGI isn't some far off science fiction concept. It's a field that's actively being researched and developed, and it has the potential to shape the future of humanity in profound and positive ways.
It's an exciting time to be alive, to witness this incredible technological revolution unfolding before our eyes. But it's also a time for thoughtful reflection and responsible action. We need to ensure that we're guiding this technology in a direction that benefits all of humanity, not just a select few.
I wholeheartedly agree. The future of AI is a future that we must create together with wisdom, foresight, and a deep commitment to ethical principles.
And to our listeners, I encourage you to stay curious, stay informed, and join the conversation about how we can ensure that AI develops in a way that benefits everyone. As always, thanks for diving deep with us.